Okay, on the bench today we have a Johnson Viking 4740. This is a 40 channel AM sideband radio. Not going to go into a whole lot on this. I think I've done one video on this, and some of the other with similar chassis. The ones with similar chassis, some of those, basically everything is flipped. Well, not this direction, but PLL cans over here. Everything that's over here on this board is on this side. Everything is literally, it's almost like a mirror image. So if you were to hold a mirror and look at it, everything's on opposite sides of the radio. But just wanted to go over a few things with this one. Now, the customer sent this to me. He had done a recap job or replaced all the electrolytic capacitors. He did miss a couple, two underneath of the wiring harness here beside the relay and between the heat sink and the relay, and then another one right down in beside the crystal filter. So I've gone ahead and replaced those. I did also upgrade this large capacitor right here. Otherwise, all the electrolytics he replaced are fine, good quality, Nichicons. I think I saw some Nippons in there, and Matsushitas, Panasonic. So, all good quality caps. Transceiver alignment's been done on it, and it now works good. But when he sent it to me, he said it didn't work. Now, the first thing I did was I cleaned the bottom side of the circuit board off, even before I resoldered, or, before I replaced those couple capacitors. So I cleaned all the solder flux residue off. I then turned the radio on, and I did have receive, but I did not have transmit. Or at least not enough to reflect on an analog power meter. Now, I don't know if it was receiving when I first got it or not, because like I say, the first thing I did was clean all that residue off of the board. So what I actually found, the reason it had no transmit, was, well, actually the troubleshooting. So, as I've said before, and it's a good place for new people to start, or even seasoned techs, grab your service manual and go to the alignment procedure, because there's a lot of test points that you'd have to go through in an alignment that are good places. That way you're not just looking in the radio and trying to figure out, oh God, where should I check for signals? Well, when you do the synthesizer alignment on a radio, you're going to be hooking up a scope probe basically to everything that generates a frequency in the synthesizer circuit. So that's a good place to start. So that's exactly what I did. So I checked everything in the synthesizer. It was working fine. Now there is one downfall here, not with this model of radio, but with this specific radio right here, and that is somewhere at some point in time someone has worked on this. They've done a channel mod. Yeah, that's no biggie. And what they did was they repurposed the dimmer switch, which is a pull switch. So that's now a channel mod, and then the CBPA is also part of the channel modification. So it's a 2-switch mod. But that's not the problem. But whoever worked on it, this should have 2 RF shields. Here's one of them. This goes over this can right here. There's supposed to be another one on top of the synthesizer can. It wasn't in the radio. I contacted the customer and he said it wasn't in there when he took the cover off of the radio either. So that's missing. And I don't think I have any more of those. So I'll probably end up making something to stick over that. And the reason that's kind of important, the manufacturers would not have gone through the expense of making these cans and these lids if they didn't need to. If they didn't need to, they would have just mounted all the components on the board with no shielding. The shields are in there for a purpose, people. It's just that, a shield. You don't want signals getting into this circuit. A lot of this has to do with actually all of this pretty much has to do with your sideband synthesis. Okay, so there's a crystal down here, and then this is where you null your carrier. Okay, with these three, with the resistor, the variable capacitor, and the transformer right here. But so you don't want signals getting in here, and you also don't want signals getting out of here, because the frequency that's coming out, this is pretty much a standalone module, this board. So you have this board, other than the channel selector, of course. But so you've got the board, the channel selector, power, and there's an output. It's this little coax cable right here, okay? Comes out actually right on that pin right there. That's the only frequency that should be leaving this synthesizer circuit, is out that pin, down in and out the back side of this can, through this coax cable. All of the other frequencies that are being generated in here in the mixing process, you don't want getting out, because that's exactly what they can do, especially since it's so close to like the sideband, a lot of your sideband circuit. You don't want those signals getting in and mixing in with it, or in with the receiver circuit, or other parts of the transmit circuit. So those shields are important. Like I say, manufacturers don't put shit in radios they don't have to, because that just costs money. So, you know, they're important. But back to the problem, it had no transmit. So like I say, I went through, checked, didn't actually align it. I just went through and checked, make sure I had signals where I was supposed to. Everything was fine. So the next thing I did was I just grabbed a Scope Pro, fired the scope up, hooked the scope directly to the coax jack on the back of the radio, and keyed the microphone in AM. And I had a very teeny tiny signal there. It was about maybe 20 or 30 millivolts, something like that. And that was it. So at 27.185. So it was on, on frequency, had modulation. It was just extremely low, just not enough to barely, even tickle the needle on an analog power meter. So now, like I say, I had cleaned the board. So, I went ahead and, actually, let me just turn this off. So I had cleaned the board, because there were a couple little solder balls and whatnot on there. But, so I get to the underside, so, I know I have power coming out of the coax jack. So, you can start at either end of the RF chain. Where do you want to start? At the beginning of it and go through and follow it and make sure, where it's being amplified and then where the amplification stops, or you can work backwards through the circuit. So I just worked backwards through the circuit. So we have the final transistor and the driver transistor. So I checked at the final. I had a small signal going in and a larger signal coming out of the final, so the final appeared to be working fine. I got to the driver. I checked the output. I had a small signal there. I got to the input, or the base, and I had a huge signal in comparison to the output, or the collector, which is completely backwards. You should have the signal on the output of the transistor, after it's been amplified, should be considerably bigger than the signal going into the transistor. So we obviously had a problem here. I know the next thing to do would be to grab your voltmeter and check your voltages. See if there's something else wrong in the circuit, or if it's a bad driver transistor, which is, very possible. But before I even grabbed anything, I got to looking at the board a little bit closer, and what I actually found, and I had it's on the bench here somewhere, I don't know where. There's a little teeny tiny speck like that somewhere laying on this bench that's actually a teeny tiny splatter of solder. It was shorted between these two traces right here. And that's what I did. I looked really close and I was like, there's a little tiny spot of solder there. And I just took, I think this ceramic screwdriver and went, bick, and it popped right off. And when I scrubbed this board down, it didn't come off, so it was stuck on there, so in between these two traces. But like I say, with a little, ceramic screwdriver, it popped right out. Keyed the microphone, output power was fine. That's all it was, shorted trace. Now, I honestly think, I don't know for sure, but I think the customer might have done that himself. And actually, there's still a blob like that. Christ, I've got to find it now. Where in the hell was it? There was another one on this board. It's not a dead short right now. There it is. Right there. I don't know if you can even see that little speck. If the camera will focus or not. Pull back a little bit. Try. Now, I done lost it again. Where in the hell was it? Right there. I put my screwdriver down here so I don't lose the damn thing. Okay, so if you look right to the left of my screwdriver, see that little shiny spot right there? That's not supposed to be there. That's what I call, solder splat or splatter. Okay, if I touch it with my screwdriver, I can yep, there, see it just popped off. There it is right there. That is exactly what was shorted, and it's now actually stuck to the tip of the screwdriver now, because there's a little bit of wax on here from doing the alignment. So it's right there on the tip of my finger. That tiny little speck right there. But that's what I had. over here was a tiny little speck of solder. And I think I know what caused that, because if I'm not mistaken, he uses a suction bulb style desoldering iron. So actually I have one. I never use it. It's been years and years since I used it, but I'd keep it for demonstration purposes, especially stuff like this, to show how not to use them. I get the feeling that's what caused it. These are great for causing splatters of solder, because as you can see, it wasn't a spherical ball of solder. So it's not like when you're soldering and sometimes you'll get little balls will bounce off on the board. That's why one reason I recommend cleaning the flux off when you're done working on something. It's to remove all those little solder balls. But when you use one of these desoldering irons, a common problem I see with these, you have to remember the solder that gets sucked in has to be pushed back out. It's not like the type of desoldering iron, the vacuum desoldering iron that I use, that actually has a collection chamber, and then you either, depending if it's this disposable or the glass kind, like right now I have my reusable glass chamber in here, okay? And I just empty that out. Or I can stick the cardboard tubes in there that are disposable, so when it gets full you just toss it in a trash can, you push a new one in. But basically in that style, once the solder goes in the tip, it never comes back out. These are completely different. When you squeeze the bulb, okay, the proper way to use this would be to squeeze the bulb, put it on the solder you want to remove on the terminal, wait for the solder to melt, suck it out, lift the iron up off of the board, and then go like that a couple times into your container, whatever you're using to collect that molten solder, but you have to blow it back out of the iron. There is no collection chamber in this thing. What goes in must come out. Unlike the other one, it goes in the tip, and it basically comes out the other end. So the problem I see with these is people either when they're bringing this, it's hot, they haven't desoldered it yet. They'll squeeze the bulb, and then they'll put it on there and suck it out, but that's the problem. They squeezed it over top of the circuit board. When you cleaned it out like that, if there was any solder left inside of this, when you squeeze it when you're over top of the circuit board, there's a chance molten solder is going to spray out of there. And that's exactly that little spot you saw there and that spot that I removed over here. That's exactly what they look like. Little solder splats or splashes of solder, because they're not little balls. It was a molten, hit the board under force, went. So just be careful. And by the same token, don't set this on the component you want to remove, wait for the solder to melt, then squeeze it and suck. Because if you set it on the component, wait for the solder to melt, and then squeeze, you're going to do the same thing. You're forcing air out, and it blows the solder out in 360-degree direction away from the pad. So the only time you should be squeezing this bulb is when the end of this iron is away from the circuit board. Never ever squeeze it when it's over top of the circuit board. So there's just a little tip. Now one other thing I'm starting to see a lot more, specifically on these chassis radios, and not only these radios, lots of other, and it's not even just CBs, ham radios, home stereo systems, automotive radios. I'm starting to see it because I work on a little bit of everything, mainly CBs, but I work on, often tell people if it has an antenna hooked up to it, odds are I probably work on it. But I replaced two of the polydip, these green polydip capacitors in here. I replaced them. Now I did a separate video on it, titled something like Green Polydip Caps Gone Bad. And I think that might have been actually in a 4740. It was a very similar chassis. If it wasn't a 4740, it was the same style chassis. But here are the bad caps. Now, unlike some of the other radios I've done where I've had to replace several of them, this one only had two. I'm actually getting them out of my little tray here. Actually had two of them that were bad. But it's kind of hard to see. But they take on a little sparklies all over them. The best conclusion I can come to, and a lot of other people, is the epoxy, because what actually happens is the epoxy is shrinking, and eventually, I think this big one actually has started to crack out at the top. Yeah, I don't know if it's enough there you can see it on camera, but along the top edge it's actually got a crack in it. But it's like the epoxy is decomposing. it's breaking down, it gets this, it's not mold and mildew. There's a chemical process apparently happening with this epoxy, and like it's off-gassing, and it crystallizes on the outside. And if it gets bad enough, I've actually seen it in other radios, I think actually in that video I did, where when it off-gassed, that crystalline residue is then stuck to the surrounding components. Now, it doesn't seem to be harmful to anything. The problem is, it may be harmful to our lungs. That was one of the things I was concerned about is, do I have to work Christ, is that another thing I got to worry about for health concerns, this white crystalline crap that's on the outside. But as far as electronics go, it doesn't seem to cause any problems. It doesn't cause corrosion or anything. But the problem is, once this epoxy shrinks and cracks, it's encased in epoxy for a reason. It's meant to make it environmentally sealed, so moisture cannot get into it. Well, as soon as you get penetration through that epoxy coating, then moisture can get in there, and the aluminum foil that's in there can then start to oxidize. It can short out, cause the same problems you have with electrolytic capacitors, basically. So just be aware of that. They're easy to spot. They'll usually do like this. It's darker color. The color starts to change, and you'll start to see that crystalline look. So if you ever see any of those, even if it hasn't cracked or split open, I've even seen them where the shell just completely breaks apart and falls, just disintegrates. It's so bad. But if you ever see any of them with that white crystalline, residue on the outside, replace them. Because if they haven't cracked open yet, they're not far from doing it, and then you're going to start having problems. So that's just something to be aware of when you're working on, like I say, not specifically these, anything electronic that has green poly dips. And it seems to be, I'm assuming, from certain manufacturers, because usually whenever I see those go bad, the markings that are on the ones that are going bad all look to be the same, and then the markings on all of the other green poly dips are a little bit different, like they were from a different manufacturer probably. So, bad batch of epoxy, I don't know. Not, like I said in that video, I'm not a chemical engineer. All I know is it causes problems. If you see that stuff, change the caps. They're cheap. These green poly dips don't cost that much. So there you go. Just a quickie, video with a few tips on the Johnson Viking 4740. Now, unfortunately, it looks like someone at some point in time has tried to re-silver the lettering on the faceplate, because these are actually, stick up proud up off the surface. You can see that they actually stick up. It's not printed on, like a decal, like most radios have there. You can actually feel it. It's actually the plastic stick. Those letters stick up. The problem is, it looks like somebody either used one of those paint markers or a silver Sharpie or a paintbrush, and they painted them, but they applied way too much, and of course it ran down in, and now it's just a blob, and you can see there's a mess there. I guess they tried to clean it off, and this, it just doesn't look very good. So now I've got to try to get that off without taking the black off. So I'm going to hope that some Testors paint brush cleaner will remove that. So I'll get that cleaned off. But the whole trick to doing this without having all this paint leached down in so it becomes a blob like this, very tiny amount of paint. I will usually set this, stand the radio basically up between my legs. I have a really fine artist paintbrush that I've cut almost all of the bristles out of. There's like maybe 5 or 6 bristles in it, and I get just a tiny amount of paint on those bristles, and will actually go, I don't just wipe across it with a big brush. I literally go in with just a couple bristles and actually go over and very, very gently repaint every single letter. But in manufacture, I think they probably use a stamping pad. So, after this plate was made, they'd come down with a, basically a flat sheet of rubber that would have a coating of paint on it, and it would just touch the face. But, it's a controlled amount in manufacturing. It's easy for them to do. But, unfortunately, somebody tried to do it and goofed it up, so now I got to try and fix that. There's a little bit of oxidation here, so actually I'll pull the knobs off, tape off the black here, and get a little bit of chrome polish and see if we can get the chrome polished up a little bit and re-blacken in the Viking letters in there. So otherwise, radio's in good shape. The cover's good, but it's back up and running now. So I got a little bit of faceplate cosmetic repair to do, and I have to, like I said, I'm going to look, but I think I've used my last one. Big thing there, people. If you take the blasted shields off, put them back on. They're there for a reason. So there you go. Viking 4740. Okay, and here's my, I don't know, 3, 4, 5 minute, however long it took. Wasn't very long, but my, guess you could call it Field Expedient RF shield. So we now have a shield. So just took a piece of fish board, insulating cardboard, just to make sure, it does have the little tabs fold over so it can't come up and, touch the underside of the shield. But I'm one of those better safe than sorry guys, so just a piece of fish board to stick in there, and then just a piece of, aluminum. I always have a sheet beside the bench, and just really quick trimmed it out and fold over the ends, cut a couple little tabs down on the side. No need to go out to the sheet metal break to cut out a, turn this into a hour long project when I can just make it right here, basically in my lap. Just 4 little tabs that line up with these notches, and then it snaps right on, and it gets the job done, and that's all that matters. So, don't need to have the holes in there, because anytime the only time you need to get in here to the adjustments, you have to have the shield off anyhow, because you're in here with either an oscilloscope probe or a frequency counter taking a measurement. So even though they put these nice holes in these, in the shield, they really serve no purpose, because if you're doing an alignment, it has to be off anyhow. So, like I said, there's no need to go through the hassle of trying to transfer all those holes into here, because they don't really serve a purpose. So there you go. I just thought I'd tack that on there to show, you don't need to make it more complicated than it is. It doesn't need to be, extremely beautiful either, because it's on the inside of the radio. It will never be seen again until, hopefully, 30 years from now, somebody else might need to work on it. But, it does its job. Keep the RF in where the RF should be, and keep it out of other circuits. Okay, so you can see we have the Johnson Viking 4740 put back together now. As I had said, it's probably, I think, the first time you've seen it. The actual cabinet or cover is in excellent condition. Not really a mark to speak of on it. It cleaned up really, really well. You can see I got the the embossed lettering on if the camera ever comes back into focus. Hocus pocus, focus. It's going to be contrary today. In any case, there we go. Got all of the embossed lettering re-highlighted on it. Remember, it was all smudged up, and before, like somebody used a paintbrush you'd paint your house with to re-highlight the lettering, and they missed more lettering than they hit. But that's all been cleaned off, and so I got all the old paint off that someone else had on there, and got the letters retouched up with some Testors model paint. So looking really good. And while I was cleaning it up, I discovered something that I don't know what it is with me and customers' radios. And I don't think most of the customers seem to ever realize it until I tell them. But this is another rare one. So let me pause it for a second, and we'll get the radio flipped around. Okay, so here we are on the backside now. And looks fairly standard, which it is. Still all original. If there's one downfall to this radio I really don't like about it, it's the rear-mounted mic jack. But hey, what are you going to do? So, but what's rare about this is, if we look down here at if I get my camera to sit level, bottom right-hand corner, this is serial number 15. So I don't know if this was a real early prototype well, not prototype, but a real early one, because a lot of times when you see stuff engraved in a radio, that's, owner's markings, will be their social security number, or, something like that. Doesn't look like it on this one, because all of these are actually the production number. So, the production code was AO27-77144. So that's exactly it's described in here. So, yeah, I don't know if this was a, pre-sales one, or, kind of like a test run. But, yeah. 000015 is the serial number. So, an extremely rare radio. I've never worked on one that had that low of a production number. So, and these radios, I always use as a good dating, I guess you could say a good way to date a radio is when the Sam's manual came out. Because Sam's, of course, Sam's had to wait for the radios to be released before they could get their hands on one. And then however long it took them to, go through and completely reverse engineer something, draw up their own schematics, parts lists, and whatnot. So, that's not going to happen in a day. That's a timely process. So, in the case of this radio, we can see that the Johnson Viking 4740 Sam's manual was released in August 1978. So, that should give you an idea of the date, time period for when this radio was released. So it's going to be before that. Well, if you look at the production code, the ending 77144, if I'm not mistaken, I got it written down somewhere. I got to go look it up. But I think Johnson Radios, I think that's the last 2 digits of the year, and then these 4 digits are the day of the year. So it's a Julian date. So it was built the 144th day of 1977. So, and if the Sam's came out August in 1978, yeah, I'd definitely say this is probably correct. This is serial number 15. So, ultra super low 2-digit serial number. So, really nice radio. And I believe the customer might be selling this one, because I think he already has one, if I'm not mistaken, maybe 2. So this one may actually be showing up for sale. So don't be surprised if you see this radio show up on eBay. So there you go, the Johnson Viking 4740.